Okay, so I see that there's someone else who has popped in. I'm just waiting for at least one more student to pop in. So for meanwhile, just be on standby. So just in case you are having connection problems, don't worry. After the live stream is over, you can go ahead and watch the video. Woohoo, we got one more person popping in. And let me just double check on the third person. Yes. Okay, so we are indeed waiting for a third student to show up. Third. So with this little chat feature, yeah, you can go ahead and watch me in your pajamas if you'd like, or you can, and if you have any questions, just go ahead and type something like what you've already done. You can ask your questions there. So we're just waiting for the third person, but let me just go ahead and move the camera. Blue. All right. So for today, yesterday we were talking about fractions. We talked about adding, subtracting, and multiplying fractions. Now we're going to be going into dividing fractions just to finish off that section. And it might sound a little scary, but truly you're going to be using multiplication but backwards. And I'll go further into that once the third student pops in. Also, we're going to be talking about ratios, proportions, and percentages. So for the beauty of this course is that we can spend extra time if we need it, or we can breeze past certain sections. Like with number sense, the first lesson, we just went through that very quickly because that was very basic mathematics. Go ahead and just shift this a bit. There we go. So I just want to verify on your screen, because what I'm seeing on my computer screen is, oh, excuse me. It was my assistant. The camera's the other way. There we go. So we're going to be talking about ratio, proportions, and percent. So these ratio, proportions, and percentages are going to be going very well hand in hand. Okay, so I think we have yet another person. Let me get closer to the computer. All right. So the beauty of this live stream also is that you can like go back and like kind of rewind just like a normal YouTube video, and then you can catch up. So we're just going to go ahead. Yay! Okay, great. So we have the other student. So let me go ahead and scoot these things forward. Great, so we're going to begin now. Move this. Okay, so let's go ahead and erase. Now, here, unlike with Zoom or with Microsoft Teams, I can't hear you. So I'm just gonna wait for count to 3 seconds, and then I'll erase the board because I can't truly ask, can I erase each time without bogging down the whole chat? So let's get right into it. Fractions. So dividing fractions. So what we saw when we were multiplying, so let's do a little comparison. When we multiply, let's see, we have we had to make sure that we had a common denominator. And we would just go ahead and follow the same principles of going straight across, like what we saw with addition and subtraction. Now with dividing fractions, you will basically be multiplying. And let me explain. So let's just do 1/3 divided by I think it actually makes more sense if I do, let's say, 8 divided by 1/2. Well, okay, I see one fraction, but how is this a fraction? How I had specified previously is when you multiply a number by 1 or divide by 1, you get the exact same number. So we can actually, I go ahead and erase this. So I can actually rewrite this problem as 8/1 divided by 1/2. So when we're multiplying, we have to find out, okay, well, how do I deal with this? So what you're going to do here is that you're going to flip it around. So we're going to do this. And you wonder, okay, so which one do I flip around? Am I going to flip around the first number, the second one? I'm going to flip around the number that is doing the dividing. So if we think of this conceptually, let's say we have 8 cups of flour. And I want to put them in individual bowls of half a cup. So we have our 8, and then here we have half. So we're dividing the 8 cups of flour by the bowls of 1/2. So here it is. So what is doing the dividing? That one's going to be flipped. So now that we have this, like, hey, what do you know? We have the common denominator. We can just go ahead and just multiply across. And we'll get 16 over 1, which is the same thing as 16. So now I know I will need 16 bowls if I have 8 cups of flour and I want to divide it up into half cups. I'm going to need 16 containers. Any questions? Okay, I'll go ahead and do another problem. So I'm going to wait 3 seconds to give everyone a chance if anyone's copying down anything. Okay, I'll go ahead and erase. So we were talking previously about mixed numbers and improper fractions. Just a quick little recap. Let's say I have this. This is called a mixed number or improper because it has a whole number mixed with a fraction. That's where we get the word mixed or improper from. Next we have, which is the same thing as 3 over 2. This is called a proper fraction because we're only dealing with fractions. So let's say that we're dividing fractions and we're dealing with this kind. If you hear a crash, that was my assistant. We need to convert from this to this whenever we're trying to do order of operations on fractions, which includes addition, subtraction, multiplication, and division. So let's go ahead and alter this word problem. So let's say I have 2.5 cups of flour. So I have a little measuring cup. So it always helps to draw to see something conceptually. It really helps to like, okay, does that number make sense? When we're going back with the 8 cups of flour into the half cups, we knew there was going to have to be more containers than the cups of flour that we were originally working with. So here, instead, we're going to deal with 2.5 cups. The problem might be set up like 2.5 divided by half a cup size container. Okay, this is a little bit more difficult to work with. Let's go ahead and turn this into a proper fraction. So knowing when we're converting from improper to proper, we know that we will multiply the whole number by the denominator and then get that value and add it to the front. So Let me just go ahead and do the steps. So this would be these two numbers multiplied right here. And then we're going to add it over here, this being the top number being the numerator. All divided over the denominator. Divided by 1. Simplifying is always going to be your best friend. You can simplify, and you can just simplify this immediately, knowing that 2 times 2 is 4. Adding 1, you can just write this as 5.5 divided by 1/2. Or you can just kind of stretch out the steps if you like into saying, all right, well, this is 4 plus 1 over 2 divided by 1/2. There's pros and cons to both methods. If I stretch it out, there is less likely that I might forget a number when I'm trying to translate it over here because you're doing two things at once. You're thinking, you're calculating, aside from having to write down numbers. But if you're stretching out too much, or if you're not too comfortable, you might end up getting frustrated. You're allowing more room for error as well. So you have to pick whichever one you're more comfortable with. So we know it's 5 over 2 divided by 1/2. I'm going to go ahead and erase to make up more space. So let me go ahead and erase. So it's still division. So what we're going to do is we're going to flip this number right here. We're going to invert it. We're going to turn it into this. 5 over 2. Now, when you're inverting it, you have to remember to change the operation into multiplication. It can happen where you're really focused and you don't change the operation, so then you flip it yet again, and it creates a mess. So just keep track. You know you flipped it when you change from the division symbol into the multiplication symbol. All right, so I can deal with this now. So I have 5 over 2 over 2 over 1. Okay, so there's not a common denominator here. This is a denominator of 2 and this is a denominator of 1. Lucky for us is I don't have to do anything to the 5 over 2. I can just go ahead and double up. Let me just color. All of this, multiply it by 2. So our denominator will equal to being the same here. So let's go ahead and do that. So we have 5 over 2. That one stays the same. Here we're just kind of like changing from like 1/2 to 2/4. It's the same thing. So we have 2 times 2. So like, Miss, we're doing multiplication here, but then we have to do again multiplication here. Yes, math is like that. We have 4, 2 times 2, and then you have 2 times 1, which is equal to 2. All right, now we can work with this. So our numerator is going to stay the same. It's going to stay at 2. Now we're going to multiply 5 by 4, and that will be 20. So our answer is going to be 20 over 2. Okay, but we can simplify this further. So if we divide by 2, like, Miss, we just did division. Just break it down. We know it's the same thing as 10 over 1, which ends up being just number 10. So we're just going to need 10 individual bowls instead. And a great way to check this is going through it again. If you have time during the exam, go ahead and see, because we did a lot of little steps. If you have time, do it again, see if you get the same answer. If you don't get the same answer, be concerned. Any questions? Okay, I'll take that as a no. Also, if you do have any other questions afterwards, we can go ahead and have, you can just, after the video is over, you can just go ahead and post questions at the bottom. And I can just go ahead in the next lesson, before I teach the next lesson, I can go ahead and just review and recap. So I'm gonna go ahead and erase. So we're done with dividing fractions. That was only just a remnant from yesterday's fraction lesson. So next, we are going to go into fractions and decimal equivalents. So just how we went from improper to proper fractions, knowing how to translate between both of them, we want to, before we get into ratios and proportions, we need to know what the fraction and the decimal equivalent is. And this is kind of a prelude into like discounts and also taxes. So let's say that we want to change, we'll do something easy, to 1/4. So this is a fraction, so how can we go ahead and, we know that this is a decimal is 0.25. So we're just gonna be going through decimals and fractions and seeing that we're having the equivalent. You might have a word problem that's saying 1/4, or it might say that there's a rate of 0.25. So instead of dealing with, multiplying by 0.25, you could just divide by 4. You're like, divide by 4? Don't you mean multiply by 1/4? Well, if you remember from our previous lesson, and the reverse is also true. So let's go ahead and do a practice example. Let me go ahead and just plug in the computer because the battery is going to die. Okay. So we're going to work with 3/8. So let's see a question that says, convert 3/8 to a decimal. So we know that the fraction 3/8 basically means 3 divided by 8. We even use in our keyboard when we're typing, we don't have this kind of division symbol. Whenever we're typing something, we have to use slash, which is, it's just another way of writing the fraction. Like, oh goodness, math comes to haunt us everywhere. So knowing that it's basically a division, we can go ahead and divide this. So we're gonna set up our little house when we use division. So we're gonna divide 3 divided by 8. So you can always use a calculator to calculate this. So let me just pull out a calculator for now. So with our solution, we get 0.375. That would be our answer. We could also obtain the same answer by just doing our regular division. So 3 divided by 8. So when we're doing this, okay, so we have a decimal. How can we go back and turn a decimal into a fraction? And most of us don't have our fractions to decimals memorized, and no one expects you to. Really, the only one I remember is how much tax I have to calculate for this region of Texas. That way, when I'm like adding up my grocery, we're like, okay, how much is my taxes going to be? But other than that, no one really expects you to. So we have this decimal. We want to go ahead and convert it to a fraction because we want to be able to. Sometimes a fraction might be a little bit easier to remember. We can go ahead and do that. So let me do another problem. So here we're going to do. Can you see? Yeah, you can see. So we're going to change 0.35 to a fraction. And the awesome thing about decimals, which is the same rule that applies to American money, is that it's all divided by 100. It follows nice rules of hundredths. So if I can rewrite this essentially as 35 over 100. Yes, this is starting to look like percentages. Yes, and we'll get there soon enough. So I can do this. I can go ahead and simplify it. What is a common multiple of 35 and 100? It's 5, because let's go ahead and divide by 5 on both sides. On the numerator and denominator. So that's going to be simplified. So here, this is just simplification. And that's how we know that this is truly the same number. If I'm like what we're doing previously, where I was literally just dividing by another fraction that's not even the same, that is not. Here, I know this is the same number when I have here, and I'm going to calculate over here because remember, 5 over 5 is 1. I simplify it to 1. So dividing by 1, the same thing. Multiply by 1, divide by 1. In the end, it's all the same. It's like making like a copy. And so this one's going to be a simpler copy. So we're going to divide by 5 on both sides. 35 divided by 5, we get 7. 100 divided by 5, we get 20. So for some people, if you're thinking of it visually, like if I have a little bar, and you have it divided by 20, it's 20 pieces. Okay. So I know I can conceptually, it's 1, 2, 3, 4, 5, 6, 7. So it's that much. 7 out of 20th. Instead, if I had to like just think of it in my head, 35 out of 100, conceptually I'd have to divide this into 100 little pieces and then 35. It might be a little bit harder, but since it's we're truly dealing with the hundreds, it's a lot easier to go from 0.35 to 35 over 100 and just bounce around. And for those, sorry, but this is complicated. Okay. Which part? So I did not see the notification on converting decimals or dividing fractions. I did not see a notification when it popped up. Okay, so let me just let me go ahead and slow down. And we have plenty of time. So let me go ahead and erase this. So dividing fractions. Okay, let's go back to dividing fractions. So let me just let the cat out. Okay. So let's go into fractions. Let's just start fresh. So a fraction is just a part of a whole. So let's say I have a pizza. And I divide it into 4 parts. And I ate 1 slice out of the 4 slices. So I know there's 1 slice out of the total of 4 slices. And you might wonder, well, okay, why don't I write it like this? This value implies, because 1 out of 4 is like 25%. It means it's not more than 1 pizza. It's less than an entire pizza. But if I do this and I simplify it, that would imply that there's 4 pizzas involved, but I'm only talking about 1 pizza for now. So that's one way that you can see it conceptually. Okay, so let me go ahead and erase. So let's say I again have a party, and this time the pizza is divided into 6 pieces. And I eat 3 slices. Oh, I ate half of the pizza. So I ate 3 slices out of the entire 6 slices. The great thing with fractions is that I can simplify them. Decimals, you can't simplify them. So you're like, okay, intuitively, since this is a very easy fraction, we know it's 1/2, but let's just work through it. How can we get to 1/2? Do these have common multiples? And by common multiples, I'm talking, is there like a common number between them? So like, if we're talking about number 3 and number 6, we're talking about, how do we get number 3? So you need to multiply 1 by 3. That's one way to get 3. How is one way that I can get 6? I can get 1 times 6 and also 2 times 3. So looking at our list of possibilities, these are called multiples. Which ones line up with each other on this side? Well, this 3 and this 3 is the same. So we know that then we can just divide all of this by 3 on top of 3, which is truly just 1. Oh, I see what you mean. Okay. So when I'm doing the simplification, it makes it seem like there's another problem. Okay. So whenever I'm going to say, I'm just going to go ahead and from now on, I'm just going to use a little like parentheses to let you know I'm doing simplification. And I'm also going to be saying right here, simplify. So I'm going to go ahead and just divide by 3. And something else to point out is whenever I'm simplifying, it's whenever I'm doing something both to the top and the bottom at the same time. See how there's 2 division symbols instead of just 1? So I divide by 3. 3 divided by 3 is equal to 1. And we have 6 divided by 3 is equal to 2. So here is how we know 3 over 6. If I ate 3 slices out of 6 slices, it essentially means I ate half of the pizza. If you're trying to be very snarky with someone, you could, instead of saying, did you eat half of the pizza? You could just say, I ate 3/6 of the pizza. It's the same number. Should I go more into detail about multiples? Okay. So I'm just gonna go ahead and now we're gonna go into actually multiplying and then dividing fractions. I know for you, you only saw the back end of dividing fractions. You didn't get to see multiplying. So I'm gonna go ahead and erase this now. Oh, okay. Oh, wow. Woohoo! Okay. And someone else commented that I made a mistake on the last question was 5. So unfortunately I cannot, since I am live right now, I can't see what I've already recorded until I end the live session. So what I'm gonna do is that I'm gonna review the recording and also take into mind I may have done a wrong calculation. It should have been a 5. I'll go ahead and I'll take a picture of it and I'll just email it to you. That way you guys don't have to sit through the whole video to see what I did wrong. So I'll write it down, I'll just take a picture so you can see the right way to do it. So next, so we're gonna move on from the fractions. Is that we're gonna go back into the decimals. So here we're gonna use a word problem. And this one's gonna be involved with medication. For those of you who have to deal with the little cough syrup with children and say, okay, this child is this old and then we have to give them this much medicine this often. This is where a skill with fraction and decimals can come into play. And especially during allergy season, this is a very big time when people have to be very mindful of their doses. So let's say that for each dose of cough syrup, contains 0.25 is a medication. How many ounces are in 5 doses? And right here, just think, whoa, Miss, what did you just do? Like, we're talking about like doses and ounces and we'll go ahead and simplify it. And I'll also do another question that's going to be much easier. The next question is going to be pretty fun. So we're talking about each dose. So let's just think of this conceptually. A lot of the time when students get a word problem wrong, it's not because they don't have mathematical ability. It's sometimes bridging that mathematical ability and trying to understand what the problem is saying. Someone who doesn't have a proper grasp of like what dose means, it means like a serving or a portion. So let's say I have like the little cup that they give you the cough syrup in. It tastes really bad. They have a little cup right here with the icky cough syrup. So we have the cough syrup, and it says that each dose, inside of it, it contains actual medication. Oh, so much for that marker. And this is a good practice if any of you ever want to go into like the healthcare field, such as like with nursing, LVN, or even being a paramedic or doctor or physician assistant. So we have the dose right here. Like all of this is the dose. But within that dose, some of it is flavoring, syrup, just so like it can go down easy. And then then that's when they added the medication. Instead of being like the powder, they make a little, kind of like a little concoction. So let's draw this. So all of this is one dose. And in each dose, we have 0.25 ounces. So to write this out, we have 0.25 ounces per dose, for a single dose. So you might wonder, well, why is the ounces not the denominator instead? Always think conceptually. That's always going to be your help out. Usually when a student might structure a problem, they might see it, they might be setting up the problem, and they might do like the mathematical steps behind it, the rest of them right, but if they didn't set up the fraction correctly, it'll give them a different answer. And that answer might be as one of the options. So you have to be mindful of that. So okay, we know, reading the question, we know that there's 0.25 ounces in each dose. And going back to our pizza analogy in the beginning, you can't have, here we're just talking about one dose. We're not talking about 40 doses or, we're not talking about like 40 pizzas. We're only talking about the one pizza, or in this case, the one dose. Okay, so we have our fraction set up. Yay. Now they're actually this is a two-step problem. There's not going to be many two-step problems, but they will be some. There'll be, if I'm not mistaken, around maybe a third of two-step problems where, okay, you calculated your fraction from the word problem, and now it asks how many ounces are 5 doses. Okay, so 5 doses. One way that you can cheat is by so these are my little cough syrup little containers. And I know that each one has 0.25 ounces. And this is always just such a great way to see it conceptually. So we can just add 0.25 ounces 5 times, and we can be truly sure it is correct. But let's say you're dealing with like 48 doses, you might not have the time to draw 48 little cough syrups. So let's just, for the sake of argument, let's go ahead and just simplify this. So we know that 0.25 ounces right here is going to have to be multiplied by the 5 doses. Because we have 5 little cups. Like, okay, miss, so how do I do this? Like, if they were asking like with 48 doses, I need to know like the true mathematical way of doing it. All right, let's go ahead and do that. So, I gotta make some space. I'm gonna go ahead and erase this drawing. Okay, so we're basically multiplying by 5 doses. Over 1 dose. So here we want to get to 5 doses. How do we do that? Or we want to multiply this by 5 doses. And the reason that we know we're going to multiply instead of divide is because we're going from a set number and we're trying to increase it, because we went from each dose, which means just 1 dose, and we're going to 5. We're increasing. Whenever you're increasing something, you know it's either involving addition or multiplication. If it's something that's decreasing, like what we're now wants less than what you originally had, you're more than likely going to be subtracting or dividing. It's a good rule of thumb. So like, okay, but the denominator is the dose, and like, how do we multiply? Easy. There is a word, a term called cross-differential analysis that they use in chemistry. We're going to be actually using a small principle of it. In fact, if you want to go later and flex on Facebook or something and say, I learned a little bit of cross-differential analysis. This is what we're doing right here. Or we're just doing a word problem with proportions. So here we have 0.25 ounces divided by 1 dose. Here we have 5 doses. All over 1. And we know that we're talking about 5 doses because we're not talking about a fifth. That's why we know it's going to have to be 5 over 1. And I want to make sure it's over a 1, because when we're multiplying, we're going to be doing the strict cross. And I don't want to multiply by a 5 down here, because if I have a 5 over 5, I'm just going to get the same number. I don't want to simplify. I actually want to increase my value. Okay. So this is the part where if you're not very comfortable with fractions, you can just go ahead and just cover your ear, like, no, miss, I don't want to know what you're talking about with cross differential analysis. Like, I don't want to listen. This is where you can cover your ears. I know that I'm just going to go ahead and just cancel where it says dose here and here. And I know my units is just going to be 0.25 times 5, and my answer is going to be in ounces. If you didn't want to listen to that part, you can uncover your ears now. Right? And I know my unit's going to be ounces. So with math, you want to keep track of your units, because in your multiple options that you can select for your answer, you might have different units. And if you didn't keep track of it, you're going to have to go back and like rework the problem. It just wastes a lot of time. Instead, try to follow your units throughout. It also helps you understand the problem conceptually. So 0.25 times 5, hey, that looks familiar. It's the same thing like we did here when we drew it out. So we know that is 1.25 ounces. Any questions on this? Okay. I'm going to go ahead and erase this. We're going to be doing a much simpler one. I know whenever I mentioned something about like dosage calculation, involving like medicine and anything, people are like, okay, miss, what are you doing? Let's go ahead and erase this. Now we're going to be going and doing a similar problem, but this time with burgers. It's like, okay. So let's say we have a burger. And this is a triple patty burger. So let's say you're like really hungry and you want 3 pieces of meat, or if you're vegan, black bean burger. So let's say you're really hungry and you want to order, so you want to buy a triple patty, and by patty just means like the little meat-sized disc, triple patty burger. So here we're talking about the triple patty burger. But now you want a burger, your mom wants a burger, your dad wants a burger, your brother wants a burger, and your sister wants a burger. So there's going to be 5 burgers involved. So the question is, how many individual patties will there be in total? So right after this question, we can go ahead and take our 10-minute break, by the way. Okay, so we have 3 patties. So just so I don't have to draw 3 little burgers each time. So we know that there's you, you. So you want a little burger with like the 3 little patties. And mom. Your dad. Your sister. And your brother. So this one's not necessarily a problem with fractions, but it has the same concept. So we know that we have a total 1, 2, 3, 4, 5. We have to basically read the problem. They're not saying 5 people directly. You have to kind of like infer that. So we know we have 5 people, and there's 3 in each one. So 5 people, or 5 burgers that we're going to get. And each burger has 3 patties. All right. So at this point, I'm going to go ahead and erase the question because I kind of need some room to work here. All right, so each burger has 3 patties. We're talking about wanting 5 burgers. Cool. So we're just talking about 1 burger, 3 patties per burger. Oh my goodness, that's a fraction. You might not think of it as a fraction because whenever we divide by 1, it's just the number on top. But when you're thinking of like miles per hour as well, like let's say I'm going like 75 miles per hour on the expressway, where it's legally 75, actually I'm saying this. Or for every hour. So you can always just break apart. Whenever they say the word each or per, you know there's division somewhere. So going back to the patties. So we have 3 patties per burger and we want 5 burgers. All right, cool. So we know we need to multiply by 5. We're not going to divide by 5. We're not going to add 5. We're going to multiply by 5 because you want to get to 5 burgers. So we're just going to multiply by 5 over 1. And why we're going to multiply over 1? Because if it was 5 over 5, we end up with the same value again. We want to increase what we actually have. There's no way that we can have 3 patties and 1 burger when you're trying to deal with 5 burgers. You're going to have just a bunch of people. You're going to have 4 people with just bread and staring at you when you have patties in your burger. So we're going to go multiply by 5. And by following the rules of multiplication, we go across. So 3 times 5 is 15. So we're dealing with 15 patties. And we're talking about the 5 burgers. And so we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Any questions on the burger? Okay, so if anyone doesn't have a question, I'm just going to go ahead and go on break, and you can just go ahead and type your question meanwhile. So for 10 minutes, I'll go ahead and move the screen over here to our please wait sign, and I'll start lecturing after 10 minutes. I'm just going to put the little timer over here. Hello. So now we are going to go ahead and start class again. Right. Let's go ahead and erase. So just a reminder, class does end at 8 p.m. So woohoo, there's a light at the end of the tunnel. So we talked about fraction and decimal equivalencies. So let's go ahead and do just one more problem before we move on to the next section. So it's going to be one of those word problems where they give you like a bunch of extra information you don't need. So a popcorn company charges the following prices per 16 ounce. So for those of you, if you've ever been to like Sprouts or anything, and you have those big barrels, or like those big wooden barrels that like are almost up to your waist, and you get the big scoop, and then you put it into a plastic bag, and you're buying different quantities instead of already in prepackaged. You can kind of like pick how much you want, and then you'll have like a different price, and then the weight, kind of like when you buy certain groceries that's by weight. This problem is going to be very similar. So right here we have a popcorn company charges the following prices per 16 ounce. So you might be wondering, okay, but we talked about ounces and there was liquids and solids. I will let you know that there's fluid ounces, but then there's also ounces for like other types of measurements. So don't worry. So if the question's already using ounces, just take it as is. Because I could have a cup of something, but if I let it dry out like cement, I have a cup of something, but it's just a different type of measurement versus like how much space it takes up versus the weight. So here, this is just talking about how much space it will take up. So let's say that they have a kettle corn option, and they charge. So now this is a gourmet, so that's why the prices are going to be a little bit like high. $4.60 per baggie. The next one is peanut brittle. We're gonna make that one $6.50. And then the next one is gonna be Fruit Loop option. And that one's gonna be $8 even. Okay, so this is just the background information for the problem. Now it's gonna ask a true question, and this is where we're gonna need extra bit of information. With this, we can't really do anything. There's one more bit of information, and that is sometimes in the question itself. How much would a customer pay for peanut brittle popcorn? if they buy 64 ounces. Okay, so what the beauty of this question is that we can just go ahead and just start eliminating information. Like with word problems, there's always just a lot of information. You just want to make it easier for yourself by just getting rid of what you don't need. It reduces your chance of error. So what are we talking about? We're talking about peanut brittle. We don't care about Fruit Loop. Fruit Loop. Peanut brittle. Not talking about cut corn. See ya. All right. So how do we set the information up? We're talking about this is the price per 16 ounces. I want 64 ounces. This is starting to sound like a fraction. So you actually might see it like this. Or like if you go to HEB and they say $3 a pound for fancy beans. This is also it's also a fraction. The only difference here with ours is that our denominator is not 1. It is a 16. So right now we actually don't have to simplify it yet. There might be more that we can do later on in the problem. Also, knowing that 16, it might not work very well with 650. We're talking about money here. And I can go ahead and erase this because I already wrote it over here. Excuse me. And I'll also erase the green. So with this word problem, we are dealing with money. So for the purpose of this test, we're talking about US money. With US money, we have dollars. And then the next lowest unit of money are coins. So we have the smallest one that we have in the United States is the 1 cent. So these are 50 cents right here. I can't talk about 0.75 of a cent. It won't work well. People are just going to say, just give me the full sentence. It's very little. So likewise with your mathematical calculations, right here, just leave it alone for now. Do not try to all right, I want to get this denominator right here as a 1. You're going to end up with a lot of decimal places here. Just breathe, and let's just get through the rest of the problem. So here we have our information, and we know that I want 64 ounces. So we're talking about peanut brittle, so this was the price for it. I can just go ahead and erase this information. I do have a larger board. However, the camera would be way too far for you to see clearly. So let's set it up in where they're stacked up on top of each other. I can perform mathematical calculations much more easily. All right, so we got $650 per 64 ounces. Okay. And I want to get to 64 ounces. So here, I could just go ahead and multiply. And you might wonder, but why are we going to do, but here we're talking about 16. Don't worry, further down, it's going to go ahead and divide 64 over 16. So you can just go ahead and do this. So let me just go ahead and grab the calculator. So if we use the calculator, and just to like not make this board very messy, it's $416 per all over 16. Now remember, we can cancel out the units of ounces right here because the top and the bottom. Remember when we say that like when you have 1/1, it's the same thing as 1. But when you have any unit of measurement over the other, it becomes one and the same. So we ignore the units. That's why we know our whatever number we have here is going to be money. So 416 divided by 16 is going to be $26. That's pretty expensive for popcorn, but this is gourmet popcorn, so you can make a decision on that if you like. Any questions on this problem? If you have any questions, you can just go ahead and type it in. If not, we can go ahead and move on to the number line. Go ahead and erase. Just double check my internet connection is working and I'm not just talking to an empty camera feed. Alright, so now we're going to be talking about the number line. So now we're just going to be talking about positive numbers. I know there's negative numbers. We'll go into that a little later. Okay. So sometimes in the exam, they might ask you where a number goes on the number line. Or it might put it on the number line and ask you which one is greater. With the number line, the more to the left, it means lesser or smaller the value. And for anyone who's thinking above and beyond, like about negative numbers, if I have negative $500 in my bank account, I have no money and actually I owe money. But if I have $5,000 in my bank account, I have more money. So we have more. So with fractions, you do need to keep in mind where it's going to lie. So let's say I have 1/2. 1/2 would go there. If I'm talking about 1/3, right on there. I also know it's a smaller number. And also let's see this visually. So let's use our little bar right here. And I like to think of this little bar like from those of you with the Windows 7, Windows XP, Windows Vista days, like when you're like downloading a file or you're doing an update, it's like that's the same way to think about it. Say this is half. Okay. And then over here we have a bar with same size. This time it's divided into thirds. Okay, so we know that 1/3 is less than 1/2. It's smaller. So we know that smaller numbers are going to be more to the left. So now that we can understand that conceptually, another easy way to see it is when you have a denominator, the bigger the denominator, the smaller the number. When the numerator is usually bigger, it's a bigger number. But if I'm talking about let's say I have 1/100. This number is going to be smaller or less than 1/2. 100 is we know to be a bigger number, but since we're dividing by 100 or our denominator is 100, it's going to be a smaller number. It's going to be way very close to the 0. Now, where we do have to be very conscious is about our proper fractions. When you're dealing with the number line, you want to turn the proper fraction, and by proper fraction, I just mean a number like 101/2. I can't simplify that any further, but if I go ahead and turn it into an improper fraction, how much is 101/2? Well, it's actually just 50 1/2. All right. I know that this is a really big number. It's actually going to be all the way over there. So since we're already here on the number line, I'm going to go ahead and just do a quick little recap on our little greater than and less than symbols since we're already here. The greater than and less than symbols, they're going to become a little bit more important when we're dealing with our algebra and specifically with our systems of equation and solving for particular values. So, any questions on this? Okay, if you have any questions, you can just go ahead and type them into the chat box below. Let's say I have a number line right here. So 0 right here. 1. Yeah, right now, we're not going to deal with fractions. We just want to master right now conceptually these symbols. Less than. Well, it depends how you're reading it too. So these are 4 different symbols. And a good way that that really stuck with me when I was learning this is that you think of this as an alligator or a crocodile, and that these are the teeth. Sorry, I didn't move this check. It looks more like a lizard, but we'll just call it an alligator. And let's say that it has an option of eating 2 different numbers. So there's 2 different numbers right here. Which one is it going to go for? Yes. So if we have a really big number right here, let's say I have number 4 and number 75. An alligator by nature is usually just a very hungry animal, or well, it's not a mammal. It's a very hungry creature. It's not going to want to go for a light salad. It's going to want the all-you-can-eat buffet. So it's going to be facing or running towards the bigger number. And the same thing applies when let's say you're using further on, you're saying x is greater than or equal to 10. And the way that I'm reading this is because I know I'm reading this from left to right. So you always read the symbols so let's say we have this equation right here. We're not going to be dealing with like solving for like unknowns and like systems of equations, but just so we know how to read this. X is greater than, because we're in English we read from left to right, is greater than 10. So we know that this is fundamentally true because a crocodile doesn't want the 10. So we know the 10 is going to be a smaller number than whatever X is. Or the equal sign assumed like, well, it's the same. But this is where it gets like really tricky, and this is where a lot of people, like in high school, this is where they found just like, I thought I had it, I don't know it anymore. When they do this. Like, what is that? It's honestly the exact same thing, but again, this is where the little crocodile comes a lot in handy. The crocodile, what does it want to eat? It wants to eat the bigger number. It wants to eat X. So we know X is greater than 10. So it wants to eat the bigger number, so we're technically still reading it like this. Something I do want to point out, whenever you are flipping your X around, like when you're moving over here, you have to like rotate the sign. Because like let's say that the number 4 and the number 75, let's say that they're running away from the crocodile and they switch places. The crocodile is gonna switch places as well. And I say, oh wait, the bigger number's going this way. Let me chase that number. Same thing. Does this help? Okay. So now that we have this right here, another way to remember it is like baby shark. Baby shark is what's gonna want to eat the bigger number. So I'm gonna go ahead and erase. I'm sorry for those of you who are parents and have heard baby shark maybe a million times by now, but you'll never forget. So next, we're going to do problem. This is going to be a word problem. We have Johnny works 5 shifts a week. And that is not an earthquake, it's just I have to move the board. There we go. So he works 5 shifts per week. His boss asks him to spend exactly. Oh, we have one of those micromanaging bosses. Yeah. Oh yeah. I'm not a parent, but I've heard Baby Shark, and I hear even piano recitals, children playing Baby Shark. So right here we have a boss. This boss is a micromanager. He asks him, you gotta spend exactly half of his time project. So we have Johnny, he works 5 shifts a week. Okay. His boss asked him to spend exactly half of his time this week working on a special project. Okay. Well, thank goodness that this boss isn't too micromanager. It's much easier to calculate half of your time versus like 3/7 of your time. So now here comes the question. And with the question, we will then know how to set up the rest of the information. So we have here, how many? In fact, I should even do it with a different color. How many work shifts will Johnny devote to the project? So here, you're like, okay, we can calculate this very easily, but you might get a question that wants you to like graph it. In this era of computer testing, I think I remember I was piloting an exam, and some of the new computer-based exams when they're coming out, and they wanted also for you to graph and like place the angle and the slope of a certain equation. Like, oh my goodness, this is becoming much more detailed aside from our bubble in the answer or multiple choice. So it's becoming a lot more advanced. So it might ask you the number line and to like drop a pin, where is the answer? So here you might have like an infinite number of choices because you could pick anywhere on the number line. So let me go ahead and draw the number line. So here we're gonna have 1.5. Let me just make those bigger. 2, 3, and this is 2.5. 2, 4, 3.5, 5, and 4.5. Okay, so we're talking about 5 shifts. So since these are very easy numbers, I think all of you can just do the mental math and say, oh, 5 shifts, half of the time, 5 divided by 2 is 2.5, 2.5. Woohoo! But let's just go through the motions because we might get uglier, nastier numbers in the future. So let's go ahead and do this. We have 5 shifts per week. 5 shifts a week, 5 shifts per week, it means one and the same. So it means 5 shifts per week. And per week, I'm talking about a single week. And now we're talking about half of his time. So half of his time is essentially going to be half of his shift. So here we can just go ahead and so we can multiply it by 1/2, or we can try to divide by 2, which is essentially going to be the same as 1/2. So let me go ahead and just like show you both ways. But first I'm going to go ahead and erase. Let me show you instead of just saying it. So let's say I go like this. I got 5 shifts. And since the question asks how much time would I devote for this week, I technically can ignore this because we're already assuming it's all on 1 week. So we're just talking about 5 shifts here. Woo! Easier question. So we can either multiply by 1/2 or 5 shifts divided by 2. But essentially, whenever you're going to be multiplying by a fraction, you're going to be dividing. You're going to end up rewriting this as 5 shifts over 2. You're going to end up right back at this. But if it makes more sense to you, especially if it says half, and it makes more sense to draw a fraction as 1/2 and do this, that's fine. This extra one little step is not going to kill you. But if you already realize, if you're a super genius and you realize that you can just do it in one go, that's fine too. You don't need to. With the HiSET exam, no one's going to be asking you to show your work. The showing your work is really only for yourself to see like how you're doing the steps and to see if you have a mistake. So I'm a big proponent of not forcing you to do an extra step if you don't need to. Why waste time? I could get through more questions. So 5 divided by 2, we know that to be 2.5 or 2.5. So let's say on the computer, they give us this little number line and we gotta drop a little pin. Our little pin would be right there. We just drop the pin right there. Okay. So we did kind of go into get our feet wet with ratios and proportions, but we'll be getting more in detail about that tomorrow. Okay, so I know some of you are asking okay, how are we going to be having our assignments and our quizzes? I will go ahead and be sending out questions along with the email, and then at the beginning of class, I'll go ahead and answer them. So that'll be a great way to recap and review and make sure if there's any misunderstandings, you can go ahead and just iron them out. So we're already almost at 8 o'clock. If you have any questions, you can stick around, leave in the chat. If not, that's all for today. Hi. Yeah, if you have any other questions, you can just go ahead and email me separately, and we can do extra reviewing. I know it's kind of hard when I have to turn directly to the computer just to see what you're doing or see what you're typing. And this will be now our method of communication unless anything else arises. For tomorrow, we will be talking about ratio, proportion, and percent. Okay, and if there's going to be any other questions, you can go ahead and save that for an email because we have 1 more minute before I end the live stream. Oh, and if any of you were wondering, you guys are watching, this is actually just a little timer I have. Just there's little numbers right here on the sides. It's just that it's a little bit more worn out. It helps me stay on task compared to like using my phone as a timer, and it's really cute. All right, it is 8 o'clock, everyone. So just have a great rest of your evening, and I'll see all of you again at 8 p.m. Bye.